Hi, welcome to another episode of Yummy Data Science. In the previous episodes, we've been talking a lot about ICD, International Classification of Diseases, diagnosis codes, and we've also talked about how we can group these diagnosis codes into broader categories. And one method that we have discussed is using HCUP's CCSR category to group ICD diagnosis codes. And in this video, what I'm going to be showing you is how to create cohorts for diabetes. And our objective is to do patient journey analytics and further on survival analysis. So patient journey analytics is both an art and a science. And it is to figure out how patients progress, how within a cohort patients progress, and how the disease progresses or improves. There are various techniques for doing this, including flowcharts and tabular representations, and I'm going to be showing you a heat map. So first of all, it's very important to create a definition of your cohort. And that's simply put, a set of characteristics that defines a set of or a group of people. And in our definition, it's going to be very simple. We are saying patients with diabetes without complication in 2021 and with continuous eligibility 2 years back and 1 year forward. So you can already see that not only will we have to pull this cohort in 2021, but then we'll have to check with the enrollment files to see if that same cohort is there and to pare it down if there are certain people in the cohort that do not meet the eligibility requirements. And why do we have eligibility requirements? We have them because we want to compare apples to apples, and we want to compare people who have been in the health plan for some time. And this is especially so if there's a diabetes management program, then you want to have people in the program who have been on your health plan for a certain time and who will continue to be on the health plan, so you can see how their disease progresses and or improves. So with that, let's go to Google Colab and get started. So quick refresher, the CCR categories file that I'm reading, master categories CSV, this is simply the implementation of the CCR classification system on a set of files, that diagnosis files that I had created from each setting of encounter files. And I'll say that one more time. So the master category file comes from the implementation of CCSR grouping on diagnosis files from the inpatient setting, from the outpatient setting, and from the professional setting. So you can see that I'm carefully looking at the length. And if you remember in our previous video, in this master categories file, we also had another grouper for ICD codes, and that was simply by truncating the ICD to the first 3 digits. And you can see, even though I've simplified my analysis, I'm taking a file that is a summarized view of encounters. And not only is it a summarized view, but I'm already also rolling them up by a roll up of ICDs. So it's summarized in 2 ways. And then you can see that even with the simple file, this becomes a very data intensive exercise. So what I want to show you is that this is a rather data intensive exercise because we don't have a standard data map. If we had a standard data map, if all companies were saying, okay, we are going to go with keeping our data in this format, then you could have Python libraries to do what I'm doing for you. So cohort analysis, cohort creation. And later at the end of the video, I'm going to circle back to Odyssey and how through their data model, they are trying to just do that, standardization of healthcare analytics. So in any case, back to our Python program, I'm going to be dropping the ICD trunk from here, and I'm carefully looking at the length. So I know how many rows I drop, but I know that from careful analysis that I have these flags that tell me where the diagnosis category came from, whether it came from inpatient or outpatient, and I've seen some duplicates. And they crept in because of the ICD code truncated. So I basically needed to reorder the data with descending values of these and then remove the duplicates. So I did that. And if this doesn't make sense, just take it on faith value that it's one of those data complexities that crept in because of the way the file was made. So now I want to see a distinct of CCSR category description just to get started. And I can already see that it's a fairly large range of categories. So I'm further limiting it to diabetes, and I come up with these 3 categories. So these 3 categories are going to be, one of them is going to be part of my definition of my cohort. So diabetes without complication. Now I'm going to filter for these in when the year is 2021. And this is my category description. And I'm going to get a list of Benny IDs or patient IDs. So now that I got the list, I know that there's 1,085 of them. Now I have to check on continuous eligibility. And remember, my rules were 2 years back, 1 year forward. So now I read in my enrollment data. And now I'm going to filter my enrollment data. So I do that here. And I filtered it, but now I am checking how many people do I get per year. So I know I get at 1,000 in 2019 and 138. So I'm going to limit it to a cohort of 1,000 because of my continuous eligibility from 2019 requirement. So I do that here. And now I end up with a diabetes cohort final file. And that's what this is. And the length is 1,000. So I know I'm doing the right thing. So now I'm done with pulling the cohort. I know who I've identified the patients. So technically, I'm done. I've created the cohort. But what I want to do is also simulate creating patient journeys. And ordinarily, I would do this on encounter level or rolled up encounter level data that was at a month level. But because this is for learning exercises, I'm going to do this on our CCR categories. Because remember, CCSR categories has patient ID, the year, the category of diagnosis, and it has these 3 flags. Where does the diagnosis come from, whether it's inpatient, outpatient, or professional? So I limit my CCSR cohort to the year is more than 2019, and the Benny ID is in diabetes cohort final. Okay. And now I'm going to print out the values here. And this has printed it out in descending order. And it makes sense. 2021 has the highest number of observations. So for the patient journey, what I'm going to do to make things easier is, of all the diagnoses, I'll only include the top diagnosis. So create a month column, because then the data set, if possible, can be used for survival analysis. And if the synthetic data does not have intelligent patient journeys, I'm going to build some intelligence with some few logical rules. And here I'm clearly cheating, but this is again a educational exercise. So I'm looking at the top 25 of the of the CCSR category description. And after perusing it, I think I'm going to drop 2 of them. So I did that. Now I'm going to filter my patient journey cohort data set for those categories. So this is my CCR cohort filtered. Now what I'm going to do is I am going to look at the journey just from the lens of the 3 diabetes diagnosis categories that I have. And you can see this doesn't entirely make sense. How can you have diabetes with complication, without complication, and pre-diabetes? So I'm going to do a few simple rules and I'm going to build some intelligence. And you can check this out in GitHub, but basically there are simple rules that add a little bit of intelligence into it so that the disease progression is clear. Pre-diabetes to diabetes without complications, then with complications, and some of them actually, the with complication eventually will turn into without complications. So there's some disease progression and there's some disease improvement. And then I'm also adding a month variable, and I'm doing that with randomly selected values from 1 to 12. And I did say that, look, I want reproducibility. So ensure that every time I run the code, I get the same values for month. And it did that by setting a seed. When you set a seed, then every time this code runs, it's going to produce the same exact value for month. So my patient journey data is ready. And I could now look at it from a survival analysis or use some other machine learning. But what I'm going to do is, well, I'm checking the 3 diagnosis categories for diabetes. And now what I'm going to do is I am going to I'm going to look at it by year, and I'm going to look at the CCSR categories, and I'm going to look at their count. Now, this is pretty hard to interpret. So what I'm going to do is, and this is kind of interesting. I really like this heat map because this heat map does tell you a fair bit. So this heat map is, it's got categories on the y-axis. It's got year on the x-axis. And then it has this dimension of frequency. And you can kind of tell that it is telling a story, diabetes with complication. For 3 years, we don't have it. And then you green and then blue. So it actually got better. And then without complication, you'll see we didn't have it. Then we had a little high values, even higher, then a little bit better, and even better. So I'm telling a story here. And like I said, this data, synthetic as it is, does not have patient journeys. Pre-diabetes, we have a lot of pre-diabetes, and then it just tapers off. It actually falls off because that's the way it was done in my code when I did some logical rules. So I promised to show you, as you can see, this is a very intensive data exercise for something that is fairly standard, given your code definition, given your cohort definition, and given your data set to check continuous eligibility and then build a data set of encounters for patient journey or a survival analysis should be a standardized function. And I want to put in a plug for Observational Health Data Sciences and Informatics, Odyssey group. They are coming up. They have all this code sets in R. They have standardized R libraries for creating cohorts. More importantly, what they have done is they've come up with a standardized data model. So once you have the data in a particular format, then it is easy to do it with the help of functions that pull these standardized cohorts. Well, I hope you've enjoyed the video and have learned. Till next time, thank you.